We're going to walk through example 5 from note 6.2. In the previous problems, we were trying to find the value of a trig ratio given an angle. But now, if we're given a trig ratio, can we solve for theta? Can we do the problem in reverse? And we can. So in example 5, we're asked to find the value of theta in degrees and radians, so in both, without using a calculator. So if we're finding angles without using a calculator, we have very few choices. It has to be one of the angles from the unit circle. Those are the only ones we know. And so we're going to use the special right triangles. So we need to use the special right triangles. So I am going to draw the special right triangles, and then we'll decide which one to use for each of these problems. So one of the special right triangles is 45, 45, 90. So I'm going to draw that here. So in a 45, 45, 90 right triangle, or these angles are pi over 4, if that's 45 degrees, the side lengths of the legs, we're going to call those A, and then the hypotenuse has a length of A rad 2. So this 5A has to do with the 45, 45, 90 special right triangle. I know that because the 45, 45, 90 right triangle has rad 2 in it, and now we're trying to find cosine theta if that ratio is rad 2 over 2. So theta here is the angle whose cosine is rad 2 over 2. And remember, cosine is the length of the adjacent side over the length of the hypotenuse from SOHCAHTOA. So the adjacent side needs to be rad 2. The hypotenuse has to be, when you simplify this ratio, it'll be 2. So here in this triangle, I know that the angle is 45 degrees. I can choose either one of the two angles. So let's say we're focused on this lower angle, then the adjacent side would be A, and the hypotenuse would be A rad 2. So now when we set up this ratio, so let's go ahead and find cosine of 45 degrees. That'll be A over A rad 2. And if we simplify this, we can cancel out the A's. Then we'll need to rationalize the denominator. And so cosine 45 degrees, which is the same thing as cosine of pi over 4, is rad 2 over 2. So the angle here is theta is 45 degrees or pi over 4. Okay, in the second problem, we're going to use a 30, 60, 90 right triangle. The reason I know that is because that triangle has rad 3's in it. So I'm going to go ahead and sketch a 30, 60, 90 triangle. So here I have it. I'll put in the right angle, put in the 60-degree angle or the 30-degree angle. 30 degrees in radians is pi over 6, and 60 degrees is pi over 3. So we'll have those two angles as well. And when we label these, the side opposite the 30-degree angle is the shortest side, which has a length of A. The side opposite the hypotenuse has a length of 2A, and the side opposite the 60-degree angle has a length of A rad 3. So now when we look at this, we have a choice of either choosing the 30-degree angle or the 60-degree angle as the tangent. So I think we're probably going to choose the 60-degree angle because we have rad 3 here for the tangent. So let's try that. So I'm going to try tangent of 60 degrees. Tangent is the length of the opposite side over the adjacent side. So if we choose 60 degrees, the length of the opposite side is A rad 3, and the length of the adjacent side is A. So this will be A rad 3 over a. The a's cancel out, leaving us with rad 3. So we've determined that theta is 60 degrees, or in radians, it will be pi over 3. If you had chosen the 30-degree angle, you would have ended up getting 1 over rad 3, and then you'd realize that it had to be the other angle.